Welcome to Math TV with Professor V. In this episode of Math Mashup Monday, we're going to answer the question, what is a rational number? So I want you to focus first on the word rational and notice that the root ratio appears in that word. So that should help you remember the definition of a rational number, which I have written down here. A rational number is any number that can be written as a ratio of two integers. So that means you would be able to write it in the form A over B, just as long as B is not equal to 0. Otherwise, the quantity would be undefined. A number is irrational if you cannot do this, if you cannot write it as a ratio of two integers. And every single real number is either rational or irrational. So remember, when we say all real numbers, we mean any number that appears on our number line here, where to the right, we're going to positive infinity. To the left, we're going to negative infinity. I've listed a few integers here, 0, 1, 2, 3, 4, some of the negatives. Every single real number on this number line is either rational or irrational. So what we're going to do now is look at a bunch of examples so you can feel comfortable classifying a number correctly. Okay, now we all know that there's infinitely many real numbers, right? You can go forever in the positive direction, forever in the negative direction. But just for the sake of this discussion, I'm going to draw the set of all real numbers and pretend that they're contained here in this little ellipse, okay? And I'm breaking it up into two parts, rational and irrational. I'm going to give you guys some examples and you decide whether or not that number is rational or irrational, okay? First example I have for you is 2/3. Is 2/3 rational or irrational? So ask yourself, is that number written as a ratio of two integers, or can it be written that way? For sure, it already came written as a ratio of two integers, so that's rational. Okay, what about the number 7? Maybe right off the bat you're thinking, no, how is that a ratio of two integers? But remember, 7 can be written as 7 over 1, so that's rational. That's a ratio of two integers. That's going to go over here. What about 0.5? Ooh, a decimal. How do we feel about that? Can you write 0.5 as a ratio of two integers or write it as a fraction? I hope so. Isn't 0.5 the same thing as 1/2? Well, then that counts as a rational number. Okay. What about 0, you guys? What about 0? That's rational. 0 can be written as 0 over 1, or 0 over 5, or 0 over -2. 0 over any non-zero number is 0, so that's rational. How about, I got another one for you, 0.3 repeating. So that's 0.333 goes on forever. Rational or irrational? What do you think? That one's rational. 0.3 repeating, you can write as 1/3. Yes? Oh man, it seems like everything is rational, but that's not going to be the case. Don't worry. Okay, what about a little bit fancier of a repeating decimal? Say you had something like 0.23 repeating, meaning it's 0.232323, etc. Actually, that's a rational number. If you haven't been exposed to this before, if you have a decimal that's repeating and see how every 2 digits it repeats, you can write that as 23 over 99. You just put the appropriate number of 9s underneath and bam, you have got yourself a rational number. Check it in your calculator if you don't believe me. I mean, we can get fancy. We could go 0.123 repeating right? 0.123, 123, 123, etc. Guess what that would be as a fraction? 123 over 999. And then you might have to reduce it, but however long it takes for the decimal pattern to repeat, throw it over that many nines and bam, now you've got a rational number. So this is feeling strange. Maybe you're thinking nothing is irrational. No, that's not the case. What if I asked you to take the square root of 7? Okay, well, we know 7 is not a perfect square. So if you were to sit there and punch in the square root of 7 into your calculator, you would get a decimal, okay? And it would not repeat. There would be no pattern to the digits that come after the decimal point. So square root of 7, if you want to just have like a little example, square root of 7 is equal to about 2.64575131106, etc., etc. But there's no pattern, no repetition past the decimal point. So I can't write it as a fraction. I can't write it as a ratio of two integers because those digits don't repeat. I can't put it over the proper number of nines. Like even if it took, 1,000,000 digits until it repeats, no problem. I could just put it over 1,000,000 nines, but we can't do that. So this guy is irrational. So anytime you take the square root of a number and it's not a perfect square, it's irrational. So just to be clear then, what if I asked square root of 36? Is that rational or irrational? Well, the square root of 36 is 6, which I could write as 6 over 1. So then that makes this a rational number. Ding, ding, ding. Okay. Squish that in there. Hang out there. So can you name some more irrational numbers for me? Square root of 2, right? 2 is not a perfect square. Square root of 3, not square root of 4. Square root of 4 goes over here. Square root of 5, square root of 6, etc., etc. And then I'm going to add two more very famous irrational numbers. We've got pi. It was Pi Day recently. Pi is approximately 3.1415926, etc., etc. It goes on forever, and there's no repetition to the digits past the decimal point. So that's why we cannot write pi as a ratio of two integers. And also we have E, which is Euler's constant, about 2.71. All right, so hopefully that was helpful, since it's going to be important to be able to classify rational versus irrational numbers as you work through your mathematics courses. And obviously there's other kinds of classifications for rational numbers that are more specific. So within this set, we have integers, we have whole numbers, so on and so forth. We can get into that in another video, but in light of the fact that Pi Day was just last week, I thought it would be fun to talk about rational versus irrational numbers. So if you found this video helpful and entertaining, be sure to give it a thumbs up, subscribe if you haven't already, and stay tuned. We've got more fun videos on Mondays coming your way for Math Mashup Monday.